All right, and welcome back. So we are still in Chapter 5, Section 4. This is the third video, so Part C. And we will finish this section in this video. So indulge me for just a second. I'm not actually going to complete this problem for you, although I do believe that you could do it on your own because it just uses derivative formulas that you've practiced before. But I want to show you a couple quick things. So the following function, right? So we have 1 over the square root of 2 pi multiplied by e to the power of negative x squared over 2. Right? So this is definitely an exponential function. And what's interesting about this function is if you've ever taken a course in statistics, right, which is, by all means, is not a requirement, but if you have, then you would have heard of concepts called a bell curve. You would have heard of concepts identified as, say, the standard derivative, or standard deviation, my apologies, I'm thinking calculus and talking about statistics. So you would have heard of concepts of, regarding bell curves or standard deviations and things of this nature. And but just to kind of make sure you understand that this function is the function that would plot the following bell curve with a standard deviation of 1. What that means, in case you've never taken a statistics course, the idea is, let's say you were to pick some type of scalable item, like the average height of adults, or the average height of children, or the average shoe size, or and you could continue and so forth, right? And the way it would work, let's say you had 100. Let's say you had, you would, or let's see if I can do my best. There's a reason why I don't teach statistics, and if I'm not careful, I'll go off on a tangent about why I don't teach statistics. But the main point is, if you were dealing with height or IQ or whatever it is, that what you would have is you would have, say, 34 plus 34, so you have little over 68% of the population would be within 1 standard deviation of the mean, right? And in this case, the mean would be 0. So right here, this is your average, right? This would be your average height. This would be your average shoe size. This is your average. Now, anyone in this portion is above average. Anyone in this portion would be below average. But if you were to, depending on the standard deviation, you would be able to capture 68%, a little over 68% of the population would be within 1 standard deviation of the mean. And then as you continue to go out, right, you would get to, say, 95%, or as you continue to go, 99%. And this is how you can have, what we call outliers, right? So if you're dealing with height, if you saw an 8-foot tall person, right, this individual would be way, maybe way out here. I don't know the exact standard deviation for height, but whatever it is, they would be really far from the average, right, from the mean. This is what sometimes they call outliers, right? They're extremely, more than 3 standard deviations from the mean. They're extremely far from the mean. Okay, now, if you want to, this particular question has to deal with inflection points. So it would require for you to take, if you recall, inflection points has to do with concavity and the second derivative. So you would have to take the derivative twice of this, which I'm not going to do. if you try it on your own and you have trouble, then I'm happy to help you. You can come see me during office hours. But what you would find is once you take that second derivative and set it equal to 0, you would get that the second derivative is equal to 0 when x is equal to -1 or +1. And that basically is pointing out that these points here are inflection points. In other words, the concavity changes, right? So we are concave down, and then we move to concave up. So again, this is just a culmination of previous math formulas and techniques that you've learned before. Only thing new would just be the new derivatives for e to the u. What's the last thing we need to be able to do before the end of this section? So we have practiced taking derivatives of e to the x and e to the u, and now we want to be able to integrate e to the x or integrate e to the u. So let's start with I won't do any proofs here, but it's fairly easy to say that if the derivative of e to the x is e to the x, then if you integrate e to the x, you also get e to the x plus c, right? Always plus c, that constant of integration. And if you integrate e to the u, then what you'll end up with is e to the u plus c. Let's proceed let's go ahead and do a few. So take the following indefinite integral. So we want to integrate e to the power of 3x plus 1, and we want to integrate with respect to x. Well, if this were just e to the x, then man, this would be a lot easier. But it's not e to the x, it's e to the 3x plus 1. So let's go ahead and let u equal 3x plus 1. Right? Because we gotta manipulate to fit this formula. So u is equal to 3x plus 1. Since it's probably been a while since you have done integration, right? Let's do this in a few steps. So as soon as you have defined u to equal 3x plus 1, that means anywhere you see a 3x plus 1, you can now insert a u. So let's rewrite this problem. And now instead of being e to the 3x plus 1, it's just going to be e to the u. And let's see if you can spot the problem. So we inserted 3x plus 1, u in for 3x plus 1. But now the problem is for us to integrate e to the power of u with respect to x. And that's a problem. You can't integrate u's with respect to x's, right? You need to integrate with your integrand should have if your integrand is in terms of u, then you need to integrate with respect to u. So the problem is the dx here. We need to get rid of this dx. Well, how do we do that? Well, let's go back over to our definition. So if u is equal to 3x plus 1, then du, that's the derivative of u, so du dx, that's just like dy dx, right? The derivative of u with respect to x. Let's go ahead and do that real quick. Well, what's the derivative of 3x plus 1? Well, that's easy. That's just 3. Now, the only thing that we do a little bit different is, this is back to that Leibniz notation, is we just take this dx and we bring it to the other side, right? Do you recall doing that back in Calc 1? So that's du can be written as 3 dx. Okay. So what does that mean? So that means if I have a 3 and I have a dx, then I can insert du. Well, look, I got the dx, right? Don't you agree? The thing I'm missing is the 3, right? I need a 3 to be here. Because as soon as I have 3 dx, then I can turn that whole thing into du. All right, well, the idea is I can multiply by 3 as long as I'm willing to divide by 3, right? If I take your age and multiply by 3 while at the same time dividing by 3, then nothing's changed, right? So a third of 3 is 1. So do you see how this is just a little bit of manipulation? I'm gonna insert a 3 here so it matches, but I can't just insert a 3 into a problem without canceling it with the 1/3. So let's go ahead and do that. So now we have 1/3 e to the u 3 dx. I promise I won't do it in the next problem in as many steps. I just wanted to, since it's been a while. So now I got what I need. So wherever I see a 3 dx, I can insert a du. So this 3 dx right here is about to disappear, and in its place is about to become du. So let's see what that looks like. So I got 1/3. I want to integrate e to the u, and now I've inserted a du. And now everything is perfect. So I can now integrate u with respect to u. Not a problem. So what is the integral of e to the u with respect to u? Well, it's just e to the u plus c. So this is 1/3 times e to the u plus c. Now, typically, we don't distribute that 1/3 to the constant. I mean, you could. It doesn't really matter. But, so I will go ahead and leave it like that. But when all's said and done, I'm not going to have 1/3 of c. I'm just going to have c. All right. So can you tell me what the last thing I need to do is? You know, I don't care if people are around. Just shout it out. Just tell me. Tell me through your microphone. What am I missing? Well, yeah, look. Your customer gave you something in terms of X. If you give your customer back something in terms of U, your customer's like, what does the U mean? What's happening? So you need to take 3x plus 1 and resubstitute back in for u, right? Your answer should be in terms of x. So when everything's said and done, it's 1/3 e to the 3x plus 1 plus c. If you leave out the c, then I have to take off points, because if you don't have a c here, then you're telling me that c equals 0. That's what you're really saying. Okay, so that's not the case. Do another one. All right, so we want to find the indefinite integral. So now this is a little busier. So we got 5 times x times e to the negative x squared dx. Well, we haven't learned a whole lot of, integration by parts and other more advanced techniques. So we better be able to use u substitution here, okay? Well, if we begin with allowing u to equal negative x squared, let's go ahead and write du right now, right? So instantly du, the derivative of u would be negative 2x dx. Okay, so let's see what this looks like. So if I were to plug a u in for the negative x squared, let me see if I have enough information to insert a du. So right now I have 5xe. Now, It was e to the power of negative x squared, but remember, we're going to insert u. We're still integrating with respect to x. So, okay. So let's see what happens here. So in order for me to insert a du, I have to have a dx. So I do have a dx. I have to have an x. I do have an x. And I have to have a negative 2. Well, I don't have a negative 2. I have a 5. Okay. So let's see if you can follow me here. So I need to have a negative 2, and currently I have a 5. But wait a minute. If I multiply 5 by negative 2 over 5, right? 5 times negative 2 over 5. That does equal negative 2. But look, I can't just multiply one part by negative 2/5 without balancing it. So if I'm going to multiply by negative 2/5 in order to counteract that, I'm going to also have to multiply by its reciprocal, negative 5 over 2. All right, because anything multiplied by its reciprocal is just equal to 1. So that's what's about to happen. So I will, just so I don't, I'll go ahead and start to set this up. So I'm going to go ahead and multiply. I'm going to multiply the integrand by negative 2/5. That's what's going to get rid of the 5 so that I'm left with a negative 2. But if I'm going to do that, then I'm also going to have to multiply the outside by negative 5/2, right? So at that stage, I'll go ahead and write what's left. So now I have 5x e to the u dx. All right, so these cancel. So now I have negative 5/2, and I got to integrate. And the only thing left is negative 2x e to the u dx. All right, well, some magic's about to happen, right? So this negative 2x and this dx is exactly what I need to insert du. So this negative 2x dx is about to disappear, and in its place is about to be a du. Listen, I know it's been a while. If it helps you see why we can do that, if it helps you, you can rearrange, right? You could bring the e to the u over here and the negative 2x over here. So it looks like this, e to the u times negative 2x dx, right? You can manipulate it, so maybe now you can see how the negative 2x dx matches. All right. When all is said and done, I got negative 5/2, to which I want to integrate e to the u with respect to u. Well, if you integrate e to the u with respect to u, you just get e to the u plus c, and then you need to back substitute for u. So negative 5/2 e to the u plus c, and the only thing that's left is to take that negative x squared and put it back for u. And we're done. To answer your question, Professor, do I have to do all of these intermediate steps like that you're doing? In other words, do I need this many steps to get to here? No. But you do have to justify, right? In other words, if you and I are having an argument, if this is your conclusion, and you and me are having a heated discussion, an argument, and you're not going to let me, and I'm not going to let you jump from here to here in an argument, right? We're going to no, back up. We're going to make each other prove why the conclusion is true. So you need to justify, right? This is your argument. This is your conclusion. All right, so that's all I'm going to go through for this section, and we kind of get the gist. You do need to try some more problems, right? You need to get some exposure, especially to some harder problems that could pop up on a test. The goal of the videos is not to do the most difficult problems. The goal of the videos is to show you the techniques and the theory. So if I can help you, please reach out to me. But if not, I'll see you guys in the next video. Take care.